Welcome back to Castellan and Cara for another installment in our series on science for growers. Today we're going to look at part 2 of the subject that we started to look at, and that is EC meters and why they are so important for any grower to use to be successful. Let's take a minute to review a couple of the things that we looked at in part 1. We looked at the issue of how nutrients were available to plants. We saw that they had to be in an ionic form. We looked at a little bit of basic chemistry of what ions were, and we know that they are atoms or molecules that have a net electrical charge, either a positive or a negative. We looked at the fact that ionic compounds, and again, ionic compounds, we looked at table salt as the simplest, but the ionic compounds that are in the nutrients that you apply to your plants. That ionic compounds are soluble when you place them in water. They will separate into the positive and negative ions or ionic compounds and then be in a format that is available to the plant. We looked at the fact that ionic solutions, water with ionic compounds or ions in that solution, also conduct electricity. So we looked at the fact that an EC meter works on the principle of shooting a small electrical charge into a probe immersed in the water and measuring the conductivity across the two electrodes, the positive and negative electrodes. As the number of ions in the solution increase, the conductivity increases, and we can convert that to a number on a digital scale on the EC meter. We know how to use the EC meter to mix our nutrients and make sure that that nutrient solution is at the proper EC level. And remember, we said that the EC meter does not allow us to determine the individual concentration of each nutrient element. It gives us a total picture of the conductivity. That was the critical reason why when you pick a nutrient product, you want to make sure that that product is based on science and is in compliance with recent research showing any updates in our knowledge base of exactly what level of nutrients and in what proportion that plant needs at the particular growth stages. So science-based products, use of your EC meter to make sure that whatever is going into the soil or into that container is at the proper level. So let's start to look at the second part of the picture. How do we monitor what's going on in the container as far as nutrients and nutrient salt levels within the container or within the soil in an outside grow application? So here is our container, or you can think about this as being the outside soil, a field plant. We've put in the proper amount. We've measured it with our EC according to our feed schedule. Now we have all of these nutrient elements and compounds available in their ionic form around the roots. The plant will be using these during the day. Its use will be driven by all of the factors either within the grow chamber or environmentally outside. The level of light available to the plant, the temperature, the humidity, the air circulation, all of these factors combine to drive photosynthesis and transpiration. The better the conditions, the faster this plant will take up water and nutrients, the slower the transpiration and the photosynthesis due to things like temperature being too low, light levels being too low, the slower the plant will respond, so that it will not be able to take up nutrients and water as quickly. So our job now is to make sure that what we're putting into the top is being used by the plant, and that we're not putting in too much or too little. We know how to monitor what's going in, so now we have to look at how do we monitor what's going on in that container or in the soil. So this test that we're going to talk about now with the EC meter is a test that I will use when I go into any grow operation that I'm doing a science evaluation on. And if there were one test procedure that I would try to get every grower of whatever crop, floriculture, tomato and vegetable seedlings, high value crops, if growers will use this very simple next test that we're going to look at, they could prevent a tremendous number of problems that they run into in growing. When I go into grow operations, probably the number one problem I see is related to nutrient imbalance between what's going in and what's retained in the soil or in the pot. Lighting is the next most common, but this EC test that we're going to look at now, I would really ask all of you to take very seriously. It's incredibly simple, and will tell you more about what's going on with your grow than probably any other procedure that you could do. So let's take a look at how to do this critically important test. The test is called an EC outflow test. The way that this outflow test proceeds, again, is very simple. Through the whole feed process, we've been making sure that what we put into the container or on the ground outside is at the proper concentration of nutrients as called for by the feed schedule. We do that by checking the mix with our EC meter, so we know what's going in is at the right level. And as we discussed, we know that the plant will take up water and nutrients. The speed at which it does that is driven by all of the environmental conditions, either in the grow chamber or outside. So the feed schedule assumes that everything's perfect, that by the time you get through a full light schedule or a full day, the next morning, just like us when we get up in the morning, it's time for breakfast to get us ready for the day. The plant is ready for another full fertigation with nutrients. But because conditions aren't perfect, the plant may not be using as much as we're putting in. And we know, as we talked from part one, that that can cause very serious problems to the plant in terms of toxicity or disruption of processes and balances in the soil, like osmotic potential imbalance. We'll talk about in subsequent videos. We want to keep this balanced with what the plant is using. So very simple test. Once or twice a week, you choose a plant or two within your grow, and you make up a nutrient solution as you always do at the proper EC. You water, and a key element of watering is watering your plants correctly. Proper moisture balance in containers is another very serious problem that is incredibly common out in the grow world. People don't understand how to maintain the proper balance. Some people, I want to keep my plants really wet. Other people, an awful lot of people, I let my plants dry out because that does whatever their buddy told them it does. There's a lot of science and tons of data. We know the moisture levels that should be maintained in grow containers. We will do a video on proper watering and fertigation and how to monitor moisture levels. In general, what we want to do when we water, every time you water anything, any crop in a container, you want to put enough in so that it saturates the grow medium and you get an outflow, meaning running out the bottom of the pot, of about 20, and some people will even go to 30% of what you put in to the top. So if you put a gallon of water into a container, the plant, the grow medium completely becomes saturated. You want to see somewhere around a quarter of a gallon coming out the bottom. If you've got your plant sitting in a saucer, you don't want the plant sitting on the base of the saucer, because you don't want this excess water going in, filling the saucer and having the pot sit in the water, so that as it uses the water here, it will then suck in capillary action the water back up into the container. What we're trying to do with this outflow is every time that you water and you have this outflow, you're actually doing a mini flushing action, which will help reduce any salt nutrient buildup in the soil. It's critical to get this 20 or 30% outflow, and then you can either dump the saucer out. What most people will do is use a wet dry vac and just suck the water out of the saucer. So during this test, we make a nutrient solution up, fertigate, get about a 20% outflow, suck it up with a vacuum cleaner. Wait an hour. And then what we do after the hour is take enough distilled water. We're trying to get water with no background EC. You take enough distilled water that you pour into the container to get an outflow of about 50 milliliter. If I remember correctly, a tablespoon is like 14.75 milliliters, so that you're looking at think about it in terms of a shot glass. You want to collect about a shot glass worth of outflow after an hour, and then test this outflow with your EC meter. Record the data and graph it. And we're going to show you how to graph the results and how to interpret them. So here's a simple graph, just as an example to show you what you want to do with this data. The vertical axis of the graph is just EC levels. 0.5, 1, 1.52, 2.53, 3.54, 4.5. It's just an ascending scale of EC values. The horizontal axis is just days. You can put whatever days you want. Day 1, 2, 3. This is just 5 days out, 10 days out, 15, 20, 25 days out. So this is assuming that whenever you take a reading, say on day 1, 2, 3, 4, you just, say on day 3 you take a reading and it's 1. You're on day 3, you go to day 3, come up, and you make a dot at the 1. These 3 lines are just examples of what your line might look like using different EC values when you are fertigating or watering your plants. The bottom line is an example. Say we were using an EC on a young plant, an EC fertilizer mix with an EC of about 0.75. This would be a very young plant, a young seedling. So we water on a day 1 and 2 and 3, and we're giving 0.75 EC. And the day 3, 4, we're up at an EC of about 1 on the outflow. As we go along, if we didn't increase this, day 10 we come out here, now it's down to about somewhere in a 0.75. We come out to day 20, we're down now around 0.5. The plant is getting bigger, and we can see that it's using more nutrients, so the outflow is now decreasing. That's showing us that the plant is using more than you're giving it, and it's probably nutrient deficient. We know that a very young plant, and we'll talk about the recommended values shortly, you only want to be using an EC of 1 for probably 4, 5, 6 day range as the plant's very small. As the plant gets bigger and grows faster, it's going to require more nutrients. But this is telling us if we didn't increase the nutrient on the input, it's going to get down and down to the point where now we've got an EC outflow of about 0.5. If the line is trending down, we're probably not feeding enough. On the other end of the scale, say we decided to be fertigating or feeding at a level where we're putting a 2.5 EC input. That's what we're making our fertilizer mix. So 4 or 5 days out, we take a reading and we're at, in that 2.5 range. 10 days out, we're approaching 3. 15 days out, we may be up around 3.5. You can see that the line now is increasing and increasing. What this is telling us on an increasing slope is now that the plant is not using as much as we're putting in, so we're getting a salt buildup, a nutrient salt buildup in the container. If we're fertilizing is somewhere around that 1.75 or 2, and again, these are just examples, and we graph and we graph, and we have a line that basically is staying stable and horizontal. This is actually what we're looking for here. So let's look at what the recommended levels are according to the current scientific data is. Which of these lines and where should we be on this outflow EC scale? For a good number of years, research by plant biologists and agronomists have been determining the proper EC input levels of all sorts of different plants and the associated appropriate EC outflow levels. If you're a greenhouse operator, you can go to a lot of the educational or extension service websites, say at Purdue or Cornell, and pull up lists of different plants, flowers, vegetable seedlings during your greenhouse production, and look at various growth stages and at early veg, late veg flowering. You would want to be putting an EC input of X, and you would like to see an EC output of Y. The data is out there. This isn't anything new. It's solid science that's being used and has been being used by commercial operators for years, because it allows them again to grow optimally and manage their business expenses and make sure that they're not wasting time and money. So I know a lot of you are involved in the production of higher value crops, medicinal crops, and are interested in what the science says about that particular sector. In the last couple of years, there's been some excellent research done looking at this particular question, and there's been a lot of data gathered. At current, the data suggests that the outflow EC during middle veg, late veg, into flowering should probably be somewhere in this 2 to 3 range. There's going to be some variation with different strains and growing conditions, but in general, 3 is currently accepted as probably the point at which you don't want to exceed without risking the potential for some toxicity problems and some disruption of the dynamics within the soil. So when you look at your feed schedule, I would say that virtually every feed schedule I look at for different companies is going to have a suggested input feed in the 2, maybe 2.5 range during the highest growth periods and the transition into flowering. So we know what the input EC is. We know that from the data, say by research of Kaplan and Zheng and Dixon, that EC outflow level of 3 is probably that upper range. So your job during your data gathering and your interpolation of your data is to make sure that your input EC is correct and that you map and your data collect and graph your outflow EC data, keep an eye on it, and try to maintain a fairly stable horizontal line with an EC outflow range in that 2 with an upper range of 3. One of the people that I know at J.R. Peters, the manufacturers of Jax, one of their top science people, recently put out a really good little bulletin on managing and interpolating EC outflow ranges. I'd be happy to forward this to any of you who would like a copy of it, and my contact data will be at the end of this video. In general, and they will explain it in this bulletin, most of the science community at the moment will tell you that when you take your EC outflow test, you will see a level that is slightly higher than the input. There's a lot of chemical reasons for that, but in general, the differential should be somewhere around 0.5 millisiemens, and the millisiemens per centimeter is the unit that we measure EC in. Don't worry about it. When you take an EC of 1, that's 1 millisiemen per centimeter squared. So that if you're putting in an input EC of, say, 1.5 during the proper phase of your feeding schedule, you would expect the outflow to be a little bit higher. And we use a guideline of somewhere around 0.5 EC higher. So that if you've got an input of 1.5, we would expect to see that outflow in that 2.1, 2.2, and as you graph horizontally, you would like to maintain that differential of about 0.5. Most of the community now will say when you start seeing a differential between the outflow and the input of 0.75 and especially 1 and over, that it's indicating that you should probably take some proactive action. And generally what that consists of is doing a couple of clear water pH adjusted fertigations to help wash out any of those excess nutrient salts building up in the container. You can also make sure that when you're fertigating, you're doing that 20 or 30% outflow to help wash out. So use a guideline of fertigate according to your feed schedule. Monitor your outflow EC. Try to maintain somewhere in the 0.5 EC outflow differential above, and a fairly horizontal track on your graphing. It's a very simple process, and again, I cannot overemphasize how important this test is to you and the success that you can realize in your grow operation. Way too often, the growers that I speak with are always reacting. They're reacting to problems because they don't test with various tests that we can do in the grow chamber So when they see their plant covered with bugs, that's when they act, instead of looking from day one for that first bug. And the same thing with nutrient management within your grow operation. If you're strictly monitoring and data gathering what's going into the top, and you're strictly monitoring and data gathering and graphing what's coming out the bottom, and you understand these simple relationships between the outs, the ins, and what the interpolation of the data means, you will then be able to react very early. If you seeing an uptick in that outflow EC, where you're starting to exceed that 0.5 level, you can take action then to bring that back down into more of a horizontal. It allows you to prevent that salt buildup, which will prevent toxicity problems and prevent dynamic imbalances within the soil. That prevents your plants from going into suboptimal growth phases. Suboptimal growth translates to loss of time, which translates to loss of money for you as a commercial grower. So if you can anticipate problems and prevent them from happening, you'll be much more successful. Keeping everything balanced in terms of the ratios and the proper dynamics in the soil will allow the plant to have its healthiest grow environment, which will mean increased productivity and increased quality of your crop, whether it's fruits, flowers, or high value crops. The happier the plant is because of the proper balance within all of the systems, the better the quality of the product. So the purpose of all of these videos is hopefully to help you understand that science is not something to be afraid of in your grow. On the opposite to that, it's something that you really should embrace, because it will just help you be a better grower and produce a better overall product. And it will also save you a lot of headaches down the road, because you'll be able to become a proactive grower. I am open to suggestions on subjects that you would like to see me cover. We can make a lot of these videos because there's a lot of science involved in growing. If you have questions about some of the science we cover in any of these, do not hesitate to get in touch with me, and I will gladly answer any of your questions. One thing you'll realize when we start talking the science of growing, when I am at business expos or at the stores to answer questions for growers, very often I'll have growers come in and they'll ask a question like, what's the best fertilizer? The more you know about science, the more you will appreciate the fact that neither I nor any science-based person can say, oh, that's the best fertilizer, or that's the best light, or this is the best control a piece of control software or control hardware, because it depends on how you grow, what your grow conditions are, what your goals are, and the fact that everything is so interlocked in this this world of plant biology, just like in human biology. If we change one factor, it impacts everything else in the chain. We can grow very successfully with HPS. We can grow very successfully with CMH lighting. We can grow very successfully with LED. But all of those have slightly different impacts on the plant, the plant's biology, the set points we want in the grow chamber. So when you ask questions, my most common response is going to be, that depends. And I will usually ask you questions. What are you doing for X, for your lighting? What are you doing as your nutrient program? Do you want to grow in an organic format? or are you using water solubles? Are you growing inside? You're growing outside. So embrace the science. It's your friend. Don't be frightened by it. We'll hopefully be able to clear up any questions you have and make things simply, or to try to simply state things so that you can look at them and say, okay, I don't need my PhD in physics or biochemistry to understand this. I get this, and I just need to understand it on this level. If you want more information, it's out there. Either I can help you get it or give you suggestions on what your next step should be if you want to investigate that area of the biology more completely. So I will look forward to seeing you on hopefully quite a few subsequent videos. And remember, you need to know what your plants need to grow.